Alright, the next thing we want to do is try and figure out how to minimize these gaps. And the reason we want to do that is because we don't want these gaps to exist at all. As you close the saw, the gaps close in, but they become like major pinch points in here. And these edges become almost like scissors, especially when you have the fence on there. And you can see it's dangerous and it doesn't need to be there. Plus, something down in here gives a great space for a miter slot to ride on. Now, what we want to do is figure out what the minimum gap we can get away with is. So this is our setup. Let's see if we can draw it up for you. Alright, parallel lines. Here's one of the sides, and here's the middle. The middle pivots from the center, but we actually minimize the gap when this guy pivots from here. Okay? And we want to know what this gap, let's call it X. Alright, and we know that this is 12 inches, so this must be 6 inches. Alright, so let's take a look at it. As you close the tool, the gaps close and they minimize how much distortion you can put on it. So here's the middle section, all closed. And what that means is that this line here is at 50 degrees. Alright, now these two lines I just drew parallel off the edges, so that's 90, 90, yada yada yada. So that means that this distance is here is 90, so we have to have 40 again. This, let me erase those because they might make it look like they're equal in distance. This has to be 6 inches. Here's our other box just to show it, and everything's, you know, closed all the way down. Alright. If we're at 6 inches here, then what's this distance? Well, this distance we'll just call alpha, where alpha is X, our gap, plus 6. Because back when we were at 90, remember, the distance from this pin to this pin along the rail is the gap X and then 6 inches. So as we close it, this can't change. So we've got some pretty basic trigonometry here. We know that the cosine of 40 degrees is 6 over alpha. So cosine 40 equals 6 over alpha. Alright, therefore alpha equals 6 divided by cosine 40 minus 6. And when we run that through Google, we get alpha equals 1.83 inches. So to be safe, we're just going to make him 2 inches. And what that means is that our gaps are 2 inches, which is about what they are there. You can see on this tool. So if we look at sort of a front view, here's our little side wing, here's our little middle wing. And what we want, since the pin on the sides has to be all the way on the edge, and it, you know, going through its little tube, this pin, you know, is the pivot point, it's everything. What we want is to put an extension that comes exactly this far, and then it'll have to extend in here 2 inches. And since this whole thing is 12 inches and it loses 2 inches on each side, that means that we've still got 10 inches for the saw carriage and all that to work in. Another cool thing about this is that our steel tube can actually extend over, and then you can just bolt on a piece of angle iron to make up the rest, so that the pin location can go here just fine and dandy. So as far as we know, this is looking good so far.